Welcome back, everyone. Let's continue looking into our while statement and let's continue analyzing why we did what we did while we declared this. Okay, now let's first of all delete these commented out statements, because from now on, especially when it comes to loops, if we're going to change the value of any variable by 1, if you're going to increase it, declare it by 1, we're going to use unary operators. We will not use these shorthand operators unless you want to increase or decrease the value by 2 or more, or you want to multiply the value by 2 or more. So for now, we will take them out, and using this regular mathematical arithmetic operator plus assignment operator will actually not look good in your code. This is actually going to be distractive. Okay, so definitely do not use this kind of a value changing and reassignment. Now, before we look at the concept of infinite loops, let's analyze what happened when we declared this simple while statement, right? That took a value of a counter variable, printed it, and decreased it, and then when the value reached to 0, it printed out Happy New Year. First thing first, this is our variable that we are going to check the condition against. While loops will check conditions against variables from outside. You have to have a variable that you're going to put inside the statement, and then you're going to check for the condition. One thing to remember, this condition has to become false sometime. So you have to create such a condition so as this becomes false sooner or later. If you say, for an example, if you say counter is less than, here we ask if the counter is more than 3, if the counter is more than 0. So this is true for the cases where counter's value is 3, 2, 1, and when it is 0, it's not going to be true, so this block will stop executing. However, let's do this. Inside the block, inside the while statement, instead of decreasing the value, which goes from 3 to 1 to 0, let's increase it. When we run this program, what do you think the outcome will be? Just before we run it, put yourself in the shoes of the compiler and say, I'm going to start running this loop. First, I'm going to take a value 3, pass it here. Is value greater than 0? Yes, it is. So then I'm going to run this block. I'm going to execute this block. I'm going to print out the value. First time it is 3. Then I'm going to increase the value by 1, which means now the value is 4. Is 4 greater than 0? Yes, it is. I'm going to do, again, print out 4, and I'm going to increase the value by 1. Now it is 5. Is 5 greater than 0? You see where this is going to? This is going to go towards a positive infinity. If you have this kind of a loop, when you run it, your program will never reach this print statement, because your program will continue until it exhausts its memory. And in Java, that's actually hard to do, because this program might run until infinity. So, or you shut down your computer, right? So that is why this is called infinite loop. And if you run it, you will see that your computer's performance goes up and your computer starts heating up. So this is very bad coding practice. Stop this, to terminate this program, because otherwise it will not get terminated. So always make sure this condition here gets to become false. Otherwise, this will run forever. If just for the experimentation, just put true here. See what happens. You get an error, which is very familiar to us, called unreachable code. Do you remember how we said do not put any statements, do not ask compiler to do anything after the return statement, right? Do you remember the return statement when we said that as soon as compiler touches it, it's going to drop everything and run away from the method? Well, compiler is smart enough to see that this code will never be reached, because when the condition inside the while is always true, this thing will always run, and the compiler will never get to reach to this. So compiler is telling you simply that, hey, do you really want to do this? Because this doesn't make no sense. This loop is going to run forever. Okay, so this is when, and if you want to, we're not going to be able to run it. However, if you comment this out to avoid the compiler from complaining, if you run it, you're going to get infinite loop again. So this condition has to be false sometimes. And if you do like this, then compiler is gonna, and let's stop this program before our computer burns up. So if you put false here, compiler also tells you that this block here is not reachable because this condition is always false. So that's why you have to put here a condition that compiler does not know for sure is going to be true or false. In this case, we said as long as the counter is greater than 0. Now you understand the importance of making sure that you use the correct unary operator. If you use plus plus, compiler will not catch the logic here. But when you run your code in the runtime, when the code is being executed, this will become an infinite loop. Okay. Now let's do this. Let's actually remove this counter. And I will comment to that. I'll not remove it. I'll just comment it out. When we don't have this kind of a counter, what will happen? Do you think this will become false anytime? For example, I don't think so. Because put yourself in the shoes of a compiler. Our counter's value is 3. Is 3 greater than 0? Yes. Which means I'm going to execute this block. Inside this block, I have one statement, says print out the counter. So next time, I go back up again, checking the condition. Is this condition true? Yes, it is, because 3 is still greater than 0. And when I run this, I'm going to get another infinite loop. You will not see much happening here because the computer is processing this so fast. But if you look at your right-hand side where let me actually stop this program. You see how many times we printed out 3s? Infinite times. And the computer is going to keep on printing 3s because there is nothing that changes the value of the counter to make this condition false. Today, tomorrow, like after 3 iterations, after a single iteration, this condition has to become false. It can be false if I do this. This is perfectly fine. And let me put the counter back up. This is perfectly fine, right? Because similar to if statements, not all loops have to run. But if they start running, they have to stop somewhere, okay? That's why we put the condition here to define when and under which conditions we're going to run these statements inside the loop. Then inside the loop, we update the condition. This is called updating the condition. So the condition changes now a little bit, and then we will just stop running. So just for the demo, you don't have to always increase or decrease by 1. You can increase by 2 as well, or decrease by 2. So let's do this. Let's put our number back. So our initial number was 3. We said, is 3 greater than 0? Yes. If I add 2 to it, this is going to become a what? An infinite loop. So I need to decrease actually its value to sometimes get to 0, right? When I run this method, my main method, look what happened now. It printed out 3 and it printed out 1. Why did it not print out 2? Because first time the compiler got to this while statement, it looked at the counter's value. It is 3. Great. Is it greater than 0? Yes, it is. Perfect. Let's run this block, execute this block. What is the value of counter now? It is 3. Great. Print it, which we printed, and decrease the value by 2. What is the value of counter now? The value of counter is 1. Is 1 greater than 0? Yes, it is. Execute this block. First statement, print out 1, which we did. Decrease 1 by 2. 1 minus 2 is equal to -1. Great, come back. Is -1 greater than 0? No, it is not. Forget this block. Don't execute this block. Get to the end of it. Continue execution from there. I have another printed statement, asks me to print out Happy New Year. Let me just do it. Okay, so this was a demo to always watch out for infinite loops. Check your conditions, make sure they're safe, they're foolproof. So one thing here, one other way to break this condition would be to input a number that is already less than 0. If I put -1, I'm sorry, this will not work in this case. So this is actually a foolproof operation. If my number is -1, what will happen is counter, this loop is not going to run. It's just going to be Happy New Year. If it is 0, this loop will not run, and it's just going to be a Happy New Year, right? If it is 1, this loop will run once, it will print out 1, but since we're going to decrease the value of 1 by 2, it's not going to print anything else, just Happy New Year. It's going to get out. If it is 2, it is going to print 2, then decrease 2 by 2. It is 0. Is 0 greater than 0? No. So I'm going to print out Happy New Year. Create test values, test for them, and make sure your loops do not run into infinity. Because in this simple example, we can catch it. However, when you create programs that consist of 100 methods, each method calling maybe a loop or not, if your program starts running, for example, let's look at this example. Let's say we don't have a print statement, right? And we increase by 2, we accidentally increase by 2. 2 is greater than 0, it's going to run, we increase by 2. When I run this program, oh, well, let's say I don't have this statement either. When I run this program, it should actually print out, it should actually continue running. Let's actually run it one more time. It terminated. So is counter greater than 0? Yes, it is. So counter plus equal to 2. So one thing I'm trying to look into, that this loop has to be a infinite loop. However, our compiler stops running it right away. Look into this operation from a different perspective, okay? So what happened here is, this is going to run towards infinity. However, our program terminates at some point. Now, to understand what happened to our program, we took out this print statement. We said that this is going to run forever. I don't want to see how it runs. And we took out this print statement. However, it looked like our program executed sometime, right? It stopped execution sometime, terminated. To find out what happened to our program, let's just create a simple print statement and put in the counter. Let's see what happened to the counter. When we run this program, what we get is negative 2,147,000,000. This is the maximum negative number of an int variable. Do you remember our first classes where we when we got introduced to primitives? We said that int has maximum negative value and maximum positive value. What happened here actually is our program kind of gave us a defect, a high severity defect, which means it gave us an unexpected output. How would you add value to a value, add positive value to a positive value and get a negative number? It means our program actually internally stopped executing and terminated itself with an error. And this is what we get as our counter. So always be on the lookout for infinite loops. Always have your test values to test for your loop, because at the end of the day, this loop it looks exactly like our custom methods, doesn't it? It has a name, it has a block, right? It has a condition, and it has a block. It is very similar to if statements. So exactly the same as if statements, this loop has to make sense. And don't forget, this condition has to become false once if you're gonna run this statement. So if you have a loop block in your code, one more time, make sure the condition will become false at least once. Thank you very much for your time. We'll keep looking into loops in our next video, and I will see you then.